So in this next unit we'll be talking about oxidation reduction reactions, which are otherwise known as redox reaction. So what is an oxidation reduction reaction? What happens? There's a transfer of an electron slash electrons from one reactant to another. So what's an example? Well, an example would be Zn plus CuNO3 going to ZnNO3 2 plus Cu. So if we analyze these, we see that this has 0 number of valence electrons. This has a never mind. Stop. And you should note that electrons lost must equal electrons gained. Yellow. So, what's an example? Well, an example would be Zn plus CuNO3 going to ZnNO3 2 plus Cu. So if we analyze these, we see that this has 0 number of valence electrons. This has a never mind. Its charge is 0. My bad. There are two other terms that scientists use. The reactant that is oxidized is called a reducing agent, and the one that is reduced is called the oxidizing agent. To answer this question, we need to know what oxidation and reduction are. Oxidation is when one reactant loses an electron, electrons, and then reduction is when one reactant gains electrons. So, based on that definition, seeing that Zn loses electrons, we can say that Zn is therefore oxidized. And that as a result, we can say that the Cu is reduced. Cu is plus 2, and then this is minus 2 altogether. Now if you look here, the Cu is 0, this is plus 2, and this is staying at minus 2. So if you see that Zn goes from a 0 charge to a Zn plus 2. Now to get that back to 0, you have to add 2 electrons. And then if you look at Cu, you go from plus 2 to Cu 0, and you add 2 electrons here. So what does this mean? Stop. There are two other terms that scientists use. The reactant that is oxidized is called a reducing agent, and the one that is reduced is called the oxidizing agent. And just to go into more depth about this finding number 2, the chart basically, the first row is the oxidation number, and the second is the total charge. And so here there's no negative or anything. So this whole total charge has to add up to 0. But if you were given something like NO3 minus, where then in that case, you know that the oxidation is -2, the total charge would be -6. Since you have to make this equal to -1, because of this negative, the nitrogen would be a +5. Okay, the next, a simple way of assigning charges to elements, and will help us in balancing redox reactions. The rules are that, number 1, an atom by itself, its charge will equal 0. So in the previous example, I said Zn plus CuNO3 In that case, Zn's charge would be 0. The second example, second rule is that ionic/metals will equal their charge number, and that you sometimes may have to figure out based on the compound that it's in. And then finally, for covalent compounds, hydrogen will always be +1, halogens -1, oxygen will be -2 except in H2O. And in redox reactions, in the first half of the redox reaction, the oxidation part, the number increases, and the reduction part, the number decreases. And just the one thing to note is that if it was in a basic solution, you would go through these same steps, but you would add the same number of OH minus ions as H plus ions to both sides. So in this case, you would get you would add just 8 OH minus plus 3 Cu plus 8 H plus 2 NO3 minus to 2 NO plus 3 Cu plus 2 plus 4 H2O plus 8 OH minus. Now this, as you may or may not know, will go into water, so it's basically H2O. You can cancel this out, cross that out, and make this a 4, and so then the final reaction will be 4 H2O plus 3 Cu plus 2 NO3 minus going to 2 NO plus 3 Cu plus 2 plus 8 OH minus. And that's what you would do in a basic solution.